Hi, everyone. Thanks for joining us for the next session of our JavaScript Buildathon. My name's Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our host for today. Thank you so much for joining.
Thank you so much, Anna. Hi, everyone. Good morning, good afternoon, good evening, depending on where you are joining us from. Welcome to day 3 of the JavaScript AI Buildathon. If you have no idea what that is, don't worry. As usual, I will walk us through a quick intro to what we are doing before we get into today's session. So before we get started, we'd really love to know where everyone is joining us from. So on the chat, please share a quick hi and mention where it is you're joining us from. I know we have a global representation, so please just greet us. If you're feeling extra chatty, you can let us know what you're looking forward to learning today from this live stream, and we will definitely be keeping an eye out on the chat. So I see we have so many people joining in. Welcome back, Mike. I know we had you on the stream on Monday from South Carolina. We do have Aquarius joining in from East Anglia, that's in England. We do have several people joining from the US. We have Nak from Michigan. Welcome. I see a few folks from Kenya. So yeah, this will be an amazing session. Welcome. And yeah, keep the introductions coming in. We have so much to cover. So I'm just going to go straight into what the Buildathon is. And quick intro, this is a virtual skilling series that will highlight some of the modern AI patterns and AI experiences using JavaScript. Why are we doing this? Most of the AI learning resources that you will come across will mostly assume that you are working in Python, but we do know that JavaScript continues to power so many applications that are used by billions and billions of users every single day. So through this program, we have curated a path that will allow you to basically experiment with everything AI plus JavaScript. So the program itself is a month long. So we kicked off this week on Monday, that was 2nd of March, and we'll go all the way to the 31st of March. The program is divided into 2 phases. So phase 1, which is the first 2 weeks, is the learn and upskill phase. This is where you'll be attending live streams like this one. You'll be attending expert-led AMA sessions like the one we'll have right after this event. And we'll also give you access to some quests for you to get very hands-on with some of these skills. And this is basically the schedule. As you can see on your screen, we'll have live streams every Monday, Wednesday, and Friday. So this is when you can join us and connect with different folks on different topics. Then the last 2 weeks will be dedicated to a hackathon. So this is where you basically apply what you'll have learned in a hackathon and get to compete with fellow builders. So you can scan the QR code that you see on the screen. This will take you to the Buildathon website, and I'll just quickly show what you expect to see there. So you will basically land on our repository. This is where we have all the quests and all the hands-on exercises that you'll be completing. And then we do have the website. So this is where you'll find a summary of everything that I've just talked about. You'll get a link to register for this series of live streams so that you don't miss any of them. And then once you do that, kindly click on this link to join our Discord space. This is where you can ask questions anytime. You can share your ideas, share your thoughts, connect with other people. And if I can just quickly show you where to go exactly, This is the Microsoft Foundry Discord server. So click on the link from the website. It should invite you to this server. And then scroll down to the hackathons and events page. And from here, you should be able to see the JS AI Buildathon. This is where we have most of the folks who are already participating, sharing their experiences. Okay, so from the site as well, you should be able to access the quests. So we started off with a quest on Foundry Local on Monday, and today our incredible speaker will talk more about what she has prepared in terms of the end-to-end experience working with models on Microsoft Foundry. So without any further delays, I'll switch back to my slides. As I said, on Monday, we were here talking about local AI development. How can you run powerful models and power offline capabilities with Foundry Local? You can catch up on the recording from that website I've just shown you. And today we have the amazing Nitya, who will be talking to us about everything Microsoft Foundry. So now scale beyond your local computer and deploy production-ready agentic experiences. So welcome on stage, Nitya. I will hand it to you. As I said, we do have an AMA right after this, so drop your questions on the chat. I'll be in the background noting these questions, and then right after this, we'll get deeper into them. So welcome so much, Nitya.
Thanks so much, Julia. Thanks for setting me up like this. I'm not that great. I just love this stuff. And so happy to see so many people. I'm seeing folks from Ohio, Kenya, Hyderabad, Bangalore. Hi, I see Ravi from San Diego. So some of you seem very familiar to me. I may have done more than I needed for this, but my goal is to excite you about building on Foundry. So as Julia pointed out yesterday on the last quest, you looked at Foundry Local. How would you build AI solutions for on-device development and deployment? Today, I want to talk you through the end-to-end model development journey on the Microsoft Foundry platform. So on this quest, we do have a repo where we have a sample. I just want to put this up to you front. This particular one, you will require an Azure subscription. It will incur costs because we're going to show you how to do fine-tuning. We're going to do evals. We're going to do red teaming. And all of that has a certain kind of like compute and token cost associated with it. But I have to say two things. If you take the quest hands-on, you must remember to delete everything at the end. Otherwise, you'll get additional charges, which you don't want. Second, I will try to record this whole thing as a walkthrough and make it available later this week. So if you want to, you can actually look at my run and get a sense of how that works before you dive in. But let's start our journey. So what am I going to cover today? I want to get started by giving an introduction to Microsoft Foundry as the platform, so you understand what this end-to-end development journey looks like. Then we'll break up our kind of hands-on segment into two parts. First, we'll talk a little bit about Foundry UI, and we'll do the setup through the portal. So I want you to get familiar with what's called the new experience, because you'll see that almost everything you do in the SDK, you should be able to come and see the outcomes in the Foundry UI in the portal if you want to. And then we'll transition over to the SDK, and you look at the JavaScript set of tasks that I've got, and kind of like talk through what you'll be doing and why. And on the right side, those are the four phases. We're going to choose a model. We're going to learn to customize it. Then we learn what observability means. And then we'll also learn how to attack our own solutions so we can assess the vulnerability to attack before somebody else actually attacks us for real. So to get started, I'm going to use this use case that we've been using on AI Tour and everywhere else. But it's mostly to frame the conversation. And for those of you who are kind of aware of this, periodically I'm going to switch over and keep my code space alive. But in this repository that we will provide to you that has all the quest content, there is a products.csv file that has a bunch of sample products for this retail store. And what we're really looking for, and we're building this application, is they want to put a customer service bot in the store. And immediately that brings three requirements. The customer says, hey, I just want to talk to it and have it answer questions in a way that helps me find the thing I need. It needs to be helpful, polite, and give me the answer I want. But to the store manager, it's like, well, if you put this there, we have a brand, we have an identity. People need to trust that what we say is right. It shouldn't be rude. It shouldn't say harmful things. So I want it to be safe and reliable. And I want to make sure that it's trustworthy so we keep customer loyalty. The architect or the engineer is saying, that's all great, but my job is also to make sure that it's cost effective. In other words, let's not be paying for a Lamborghini if the thing can be done with a Honda, so to speak, right? And so we're going to look at what we can use to actually make our solution cost effective. So what is the end-to-end model development journey when I talk about it, right? The customization journey for something like this, so Cora is the name of the customer service bot that we're building. The customization journey usually starts from, there is a kind of user coming in saying, hey, I'm painting my living room wall. What should I buy? And the response we really want is, hey, we have an eggshell paint. Here's the product. Would you like to know more? So not only am I giving you factual information, I'm kind of leading you on a journey where I ask you more stuff. How do you get from here to here? Let's try something out, right? So first, I'm going to go into Foundry. And just for the heck of it, I have a model here. And in this model, I've done nothing. I've just deployed a model and said, you're an assistant that helps you find information. I say, I'm painting my living room wall. What should I buy? What does it do? It gives me information that's largely kind of like made up or brought from the web. It's not about my products. It's not using the format I want. It's not doing things the way I want them done. So really what we're looking at is in this customization journey between the place where the question is asked and the place where it's answered, we need to engineer the context, which means we need to give the model the right information and instructions so it can provide the response the way we want it. And then we may need to do adaptation with fine-tuning for things like making it cost-effective. We'll talk about that. Now, the first thing before we start this is you probably have seen this slide in many of the talks about Foundry. And the thing you want to keep in mind is compared to even like a year ago, the way we're building AI solutions is changing fast. So in previous years, we'd be like, okay, find a model, deploy it, talk to the model, and then we have RAG. We have all these techniques to help you kind of customize what the model sees. But that's not enough anymore. Now, solutions have multi-models. You can have one model to do chat. You can have an image model to build additional things. You can get a reasoning model so you can do agents and so on. And of course, this is the year of agents. They need to also think about how you can coordinate multiple agents around a single task, how you can evaluate and protect your system from attacks, and so on. So this fundamental shift actually means that we need to think about two things. So the old way is data comes in, it's a prompt, the model, a response to the prompt gives a response, and you do something and it goes on. Now at scale, you've got multiple conversations happening with multiple agents. You need to coordinate them, and you need to be able to track what they're saying, see that they're doing the right things and all. This scale is where we really need a platform that makes this end-to-end seamless. This is what your current or modern end-to-end development journey looks like when you're using agents. You need models, of course. Everything starts with model choice. Then you need tools that'll integrate and enhance that model with both knowledge and the ability to run actions. You need observability features that let you trace it for execution, evaluate it for safety and quality, and so on. If that model is not doing what you want, you may want to fine-tune it with your data. We'll talk about that. And then you want to be able to deploy it. So this is what Microsoft Foundry looks like. And if you think about it, they call it the app and agent factory because really you've got an assembly line. You get your model, then you connect to the service, then you bring your data, then you add your actions, customize the model further if you need to, and so on. My hope is that by the end of this session, you get a kind of intuitive sense for this end-to-end cycle. And from the Microsoft Foundry perspective, it's seen as build, deploy, and operate. And I'll kind of take you over to the Microsoft Foundry, the new Foundry UI for just a second, to show you that we actually have the build, operate, and so discover, build, operate exactly in the UI as well. So what does this mean? There's governance across the board, but during build and deploy, you're building this and assessing constantly that it's doing what it's supposed to do. Once you deploy it, you move into the monitoring phase where you can see whether the performance is up to speed. And throughout, you want to keep testing for any issues that you can mitigate iteratively. So where does our journey start? Remember, we want to build this kind of Cora bot. Where do we start? Your model journey, your journey always starts with model choice. So before I get into this, I'm actually going to go in for a second and make sure that all of you who are doing the quests know how to get yourself started. So I think that in the original quest repo, you may have found a link like this. When you click on it, this is the repo that has all the source code. What I want to do is have you there are two choices. This one is the one where if you click this create code space, it will create a code space right on the repo that I own. You don't save anything, don't fork anything, it's totally fine. You can run that session, but once you run it and you delete it, it's gone. If you choose, the instructions also will show you how to fork and then create the code space, so then you have a copy. Pick your path. For convenience, if you click this Create Code Space button, you will see a tab like this open up. And it'll take a little bit of time, but what you're really getting is VS Code in the browser. Now, I can't see the chat messages right now, so just thumbs up or let me know if you're not familiar with CodeSpaces, etc. But what CodeSpaces allows me to do is give you an environment that's completely set up with everything that you need to run all the tasks. So what you're going to do is when you launch CodeSpaces, you're going to wait for a few minutes until your setup kind of shows that you have a terminal window. And let me actually see if we can run this again. It should have a terminal window. All your extensions should be loaded, and you should be ready to go. So in the README, you will actually see the instructions for how you get started. So let's look at that. Again, remember that in order to use this, and if you want to do the quest yourself, you must have an Azure account. This will incur some charges. And so kind of keep that in the back of your mind. What you're going to do, you can read all of this later, but what you're going to do is go scroll all the way to the bottom. And for getting started, if you launch that code space using this button, you can go directly to the setup. If you didn't, then this you can unclick that. I mean, you click it, it'll expand it out. It'll show you how to fork the repo and then start CodeSpaces, in which case you'll have a copy of the repo afterwards. If you click on setup, it'll take you to the setup page. This is where we are, and this is where we're going to kind of walk through this a little bit. So by now, I'm assuming that you've got your CodeSpaces running whenever you do this. The first step you're going to do is you're going to connect your development environment to the Azure backend. And to do that, you're going to do AZ login. I've already done this for obvious reasons. I don't want to do it live. But one way for you to know if your account is set up is you can do AZ account show, and it'll show you that I am connected. Once you've got this, effectively what you've done is you've created an Azure credential for your backend in your code space. And now what you should be doing, which I've already done, is you will you'll switch over to the Microsoft Foundry portal, and you will now use the UI-based approach to create a new project. I've put all the screenshots over here. So you're going to go in, you're going to watch this, switch over to the new Foundry tab. I'll show you what that looks like. When you log into your ai.azure.com Foundry portal, you're going to get something like this. You want to click on this button here and turn it purple, in which case you're going to get a screen like this. So in your case, I've already got a project, so I see this. In your case, when you kind of like slide that over, you will get, you will get a choice to create a project or use an existing project. And I have all the screenshots here. You are going to create a new project. So just walk through the screenshots, create a new project, fill in the information. I recommend that you use Sweden Central because red teaming and some eval stuff can only work in certain regions. This is one of the best regions to do everything in. It'll take a couple of seconds. Once you're done, you should get to this stage where you will see exactly this. This is my landing page. And this says, I now have an Azure Foundry project ready to go. No models, nothing, but the project is created and I have a resource. Okay, yeah, I'm not taking questions right now. Let me get through all of this and I'll come and keep an eye on that. Now here, I have a hack for you to add application insights. Now, why do we need application insights? When we do tracing, we want to be able to collect all these logs and keep them somewhere so we can go and analyze them later. You need to activate application insights in order to make that happen. So I've kind of documented the approach for you to do it, switching into the old Foundry UI for just a minute. But I will be updating this because the product team has shown me a different way where we can do it exactly where we are. Regardless, this should still work. Once you've completed all of this, I'm just going to scroll all this through. You should now be at this point where you have this project. So far, I hope you're all following me. Now, all you've got is a Foundry project on Microsoft Foundry, hasn't done anything yet, and your development environment in CodeSpaces is completely connected to that backend. Now, this is great, but we actually need to do work with models. So the next thing we're going to do is we're going to go and deploy Foundry models. So this is where I've documented it here, but let's kind of go through it a little bit live just so you get a sense of what we're doing, right? So over here, what you're going to do is you're going to go into Discover. And I want you to understand exactly what the challenge is in picking the right model for the job. We have 11K models and counting, and we kind of don't know where to start. So let's talk about how we pick the right model for the task. So remember, at the end of the day, we're building an AI agent solution that's Cora. And we're going to focus first on that heart, the beating heart of the agent, which is the LLM or the large language model. On the Microsoft Foundry, this is the platform, kind of like a very rough approximation of it. What you'll see is that all of those components, models, agents, datasets, indexes, all of those are part of the Foundry platform. They're exposed through a Foundry API. That Foundry API is your source of truth, but you can access that API using the JavaScript SDK. That's the Foundry SDK over there, or in a low-code way through the Foundry UI. That's the highlighted pink button. So for now, I'm going to just show you how to use the Foundry UI, which talks through the same API, to go look at models and pick the right model. My goal is to make sure that you're also familiar a little bit with the new Foundry UI and kind of give you a second place to look to figure out how the things are going. So let's talk about models. Microsoft Foundry has 11,000 plus models and counting. That's a lot of choice. We all get kind of paralyzed, right? Like, what do I choose? What if it changes? So how do you pick the right model for the job? The thing you need to know is, if you kind of look at this, there are two categories, right? You see models direct from Azure and then models from our partners. They have slightly different meanings when it comes to not just capabilities, but cost. So models direct from Azure are those that are directly sold to you by Azure. In other words, we will manage them. They have SLA guarantees. You should be able to do global standard and get pay-as-you-go pricing and so on. Models from partners require you to have an account to go and get it from the marketplace, but you still get them and use them in Azure using the same APIs. Still, that's a lot of models. Where do we start? So the first thing you're going to do is figure out, how do I choose? So I'm going to go back over and show you where benchmarking is. So here's my models. And by the way, let me know if this is a good pace. If I need to slow down or speed up, you can let me know. The easiest way for you to do this is to go into models and say, okay, what model do I want? There are 11,000. Where do I start? One thing you can do is you can go over and click on the leaderboard. So first, let's start with saying I'm just going to pick a model. Let's, for the heck of it, go with, I don't know, let's do GPT-5.2. Now, if I go into the model itself, you will notice that the model has benchmarks. I can chat with it right here, test it out, see how it goes. But the benchmarks that are provided is what we're talking about here. So when you look up any model individually, you can actually understand how it has compared to all other models in its class or capability, get a sense for just how that model performs on its own. This is an example of the card with GPT-4.1. But really what we want to know is, how do they stack up against each other? So while I can go into a single model card and look at the benchmarks, I can also click the leaderboard. And when I look at the leaderboard, what I'm seeing is, hey, across all the models, here are what, based on quality or safety assessments, throughput, cost, etc. These are the top models that we have. But wait, we can do more. And I've put the instructions in the README. You can kind of go in here and actually select models. So I can scroll through and say, you know what, I want to look at the difference between, let's say I want to pick some of the latest models, so GPT-5.1 perhaps. And maybe GPT-5.1 is cutting edge. It's got a lot of adaptive stuff. Let's take one generation back, like GPT-4.1. And maybe I want to take an open source model like Llama. I think it only allows you to compare 3. And then you can click and compare the results. This is exactly what I've documented. And now I get a much better sense of how these go head to head. Slow down, they say. Okay, so I'll see how much I can slow down. And hopefully we'll make it through everything. But if I look at this, you're comparing models, and you can immediately see the benchmarks against them. So here I can look at it and say, GPT-5.1 is probably the best for quality and safety. GPT-4.1 is better on throughput, but cost-wise, Llama is the cheapest. But I've also told you that in this particular quest, I want to actually try out fine-tuning. And if I kind of scroll down here, It turns out that the endpoints, currently this is the one that supports fine-tuning. So I'm going to go with GPT-4.1, right? So I'm just making it simple, but I wanted you to actually understand where you can go and look at for the data. All of that is actually documented in the setup stage. So I've gone ahead. I've said, OK, I've gone through all this. I want to have GPT-4.1, at which point I can literally just click this button and say deploy it. Now, I've already done that. So you can see I deployed GPT-4.1. As you'll see later on, I deployed GPT-4.1 mini as well because we'll do fine-tuning, and that there is my fine-tuned model. But for now, let's assume that we've deployed GPT-4.1. What do we do next? So I've deployed it directly after comparing it. I've made my model choice. I'm going to go with GPT-4.1. Now it's time for us to test that model out. How does it actually perform? So over here, I can go in and say, hey, GPT-4.1, I haven't done anything. This is the default. I'm going to ask you the question my customer is asking. I'm painting my living room wall. What paint should I buy? And when I hit enter, note that I've taken the generic instructions. I have no data connected. I just go ahead and say, hey, let's just do this. And it gives me an answer, which is not necessarily the answer related to the data I have. But I do want to take a minute to show you a few things, because the bigger part of these quests is that I want you to explore the platform. So at the bottom, you'll see that it tells me what model gave the response. It tells me how long it took, 4.8 seconds, how many tokens it cost me. And I can then go ahead and ask another question if I want to. If I want to switch over, I take code, I can. Great, I've got this set up. But I know that that's not actually doing the job because it's not customized to my stuff, right? So it's time for us to start doing some manipulation around it. So before we do that, I know we're going to have to come to code later on to do a bunch of things. So I'm going to show you how to set up your development environment in CodeSpaces to now talk to that backend so you can get access to that model. But I want to show you one more thing before we do that. And that is that what we did is we compared these models and we deployed one and we tested it. So that's mean we've done a model choice. But what if I want to actually understand the trade-offs between those three things? So I did a comparison here, but it turns out that I can also use this trade-off chart to actually put the three of them and compare them head-to-head against these requirements. So let me go ahead and do that. And you should try it out for other models. So I picked GPT-4 mini. Oh, let me actually take everything off for a sec. So we'll start from a blank slate. And I'll say, I want to look at GPT-4.1 mini. Maybe I want to look at GPT-5.1 and GPT-4.1. And what this lets you do is kind of puts it into a box. And you can see the one that you're seeing right now is slightly different from the screenshot I had over here. And that's because these are being updated every day based on the latest information, right? So over here right now, it's saying GPT-5.1 has the best quality, but the highest cost. GPT-4.1, slightly lower quality, slightly lower cost. GPT-4.1 mini has a comparable cost, much lower. I mean, it has a much lower cost for comparable quality. So for now, we've made our decision with GPT-4.1. We'll keep going, but keep in mind that GPT-4.1 mini might have been cheaper, and that's how we're going to find out how to use fine-tuning. So with this, I'm going to stop for a second and recap what we did. We just finished the first set, which is we picked the model, deployed it. Now we need to actually see if we can start customizing it so it fixes those issues we talked about. So you're going to come back into your development environment here. And what you're going to do is it's actually documented. To start the quest, you're going to run this script here called setEnv. And when you do that, it'll set up all your environment variables for you. You don't have to worry about going and copying them over from the back end. It'll just set it up, and it'll create this .env file for you. I'm not going to show you what's in it because that's got my identifiers. But once that's done, your CodeSpaces now knows about all the models you've got deployed, your Foundry endpoint, and it can start working with code. And so what you'll do then is you will actually test it up. Fingers crossed that my CodeSpace is still alive right now, but you will go ahead and build the labs out. And then let's try this one more time. All you'll do is you can see, excuse me, the quest is set up as independent tiny files. Each step can be run with Node. So over here, I'm going to run the second step. And all the second step does is it goes ahead and sees whether that script found the right environment variables. Are they all set? Am I able to connect to that endpoint? And it will actually test it out and say, hey, can I just check that that model is alive? So if you get this far, then you're good to go to start doing all the other labs. Okay. So at this point, what we've got is we've understood why Foundry is the platform we want to use, set up an account, created a project, deployed a model, set up our environment, connected to it. All the labs should now be ready for you to run. So for the rest of this session, I'm actually going to go in and talk about what you learn on the quest, and then see if we can kind of switch to the code as and when needed. But I would rather have you get a sense of what we're doing and why, and then take the AMA to ask more stuff. So remember that when we tested that model, it wasn't doing what we thought we wanted it to do, right? So it actually it's not answering the questions based on our data. So we need to customize it. So Microsoft Foundry has a ton of options for you to customize a model. So what does customization mean? It means the model response should actually do what you expect it to do. So the base model is what we've deployed. The first thing that everyone will do is prompt engineering. So that's like saying, let me go and fix it by giving it instructions and see what happens. So let's try that out really quickly. So I can go into this, and I think I had some instructions over here. So I can say, you are Cora, something like this. But of course, actually, I need to come back. We'll do this in agents, because this one I haven't actually attached the data files. But I'm going to go back out and show you that in the agents tab, I have that model connected to a basic agent. So in this agent, I can now add my instructions, as you see here. All of this will be documented in the docs as well. So I've now started customizing that model, right? I've said, hey, there's a model, but I'm giving it instructions. I'm telling it what you should be doing and how. And the next thing I want to do is, I haven't actually done RAG very explicitly, but I have added a tool here called file search, and I've uploaded the documents that we have for the products, which now allows this to be routed against those docs. So now, if I ask the same question, let's hope, I've had a quota issue this morning, so let's hope it's still working. I can now ask this same question, fingers crossed that it works. And it should now give me, oh, hang on. That was the fine-tuned model. So let's see if that works. The tools are connected. And I need the right question. Okay, fingers crossed. I have screenshots that I'll add into the chat later. So now what you're seeing is, it is answering the question, but it's actually telling you the specific products that we're using, right? And you can also see that it's telling you the token costs and the time it took. And note something interesting, and it'll lead up to what we'll talk about in evals later. It's telling you the quality of the response. It says, hey, I'm testing it for a bunch of things and it passed. It's safe. And I can actually click on these logs and see what happened behind the scenes. Okay. So you can see that the first step for prompt engineering is us basically going from, I have a base model and I haven't fine-tuned the model, but I can get further by just having it, providing it with instructions and adding my context or grounding it in context using RAG. I've used a tool here, but there's a deeper dive coming soon. And it's getting me where I want to go. But did you notice that the latency is high and I'm paying a lot of token costs? So this is where we want to think about how we can go and look at fine-tuning. So before I walk into the fine-tuning segment, let's set the stage for what fine-tuning is and why it matters. So what does fine-tuning mean? In this particular case, let's say Java, they actually have really good examples of those customer question-answer pairs. And what they've realized is that if I ask questions in a certain way and get the right response, I'm more likely to get the customer to engage and they trust it better. So how do they teach this model to do that job? As you notice over here, we can do it by packing the instructions with examples, but that's just going to add token cost, and I can't tell it every possible thing. What fine-tuning allows you to do is to customize that model, the one that I got, which is 4.1 or 4.1 mini, which I want to use, and teach it by example what the expected response is. So rather than add it at the context layer, we bake it right into the model. And it's one of the best ways for you to do this when you have personalized, like custom domain data that is not available in the outside world, or you want to enforce a certain tone, or you want to take kind of have specific criteria for how you want the response formats, safety, etc. to be handled. So why do you want to fine tune? Improve the quality, reduce the cost, and reduce latency. The improved quality you can understand. Now I've kind of taught it exactly what I want. I'm going to get domain-specific results. Reduce the cost and reduce the latency. How does it do that? So out of the box, you can say that when I fine-tune it and I ask the fine-tune model the question, I'm not using up the context window, so I can reduce token costs. And the response time is also less because I'm not processing that window anymore. It's able to answer me directly. But how about latency? Remember, one of our requirements is we want it to be cheaper. This is where we'll talk about something called distillation, where fine-tuning can be used also to take example data generated by a higher performing model and use it to train a smaller, cheaper model to do the same job. And so with distillation is really good. So you'll notice that, when you look at the fine-tune model that I actually fine-tuned 4.1 mini, which, if you recall from that Tradeoffs, is cheaper, has approachable quality. So you may ask yourself, why didn't I just start with 4.1 mini? And the reason I say this is when you start your journey, you don't know what you need to do. You may have multiple capabilities. So you pick a resource-rich model, you start using it, and then you realize, wait, the task I want the model to do is just this one thing, answer just questions, that's it. So if I can train a smaller model to do the job, it's cheaper, then I can delegate that agent to use that smaller model. And the more complex stuff, maybe there's a different agent that does it. The analogy I often use here is that it's like a store, right? The store manager is balancing a bunch of things that are tasks like inventory store, restocking, cashier, etc. Now, the store manager can do it all, but it's easier and cheaper for them to pick a person and say, your only job is to man the cashier. You don't need to know everything else about the store, but I'm going to make you the best cashier you are, and you'll be as good as me at that task. So that's what distillation will do here, is we're teaching the smaller model to answer questions using this tone and format, but nothing else. And because it's only learning the one thing, it'll learn it well and get a decent, like a comparable accuracy. So that's distillation. So fine-tuning can also be used to reduce the cost by distilling knowledge to a smaller model. So let's switch into this and kind of look at, I'm not going to go through the code. Let me just take a quick time check. Yeah, I'm not going to go through all the code, but you can find it in here. You'll see that the fine-tuning task is task 4C. But what I do want to show you is how that works. Now, when you run fine-tuning, the first thing you need to know is it's a long-running job. So over here, when you've submitted it from your code base, when you run that particular task, it will first submit the job and upload the data. So under data, it'll have uploaded your training files. Can't see it because I've got a bunch of other files before them, but it'll upload it here. The training and evaluation files are in that repo already. And then it will run a job. So if you then click, once you've run that particular task, wow, my screen is so slow. It will actually submit this job, and you'll find it under the fine-tuning tab in the Foundry. And if you look at it, when it starts off, there, by the way, the UI is currently kind of being updated. So you may see periodic little errors, but they don't actually cause you to have any issues. They mostly are like, hey, there's a small delay and stuff, etc. So what you can see in this is that the first thing you'll notice is I queued the job up very early in the morning. It took over an hour to complete. And that's on a good day. It could take way longer. We have no way to tell. But what you want to look at, or what you want to understand in fine-tuning, is three things. First, when I submit the job, it gets queued. The first thing it's going to do is, let's look at it, right? it's going to pre-process your files and make sure that the data is in the format that you want, and that it has got enough data, and every row of data that you've given for fine-tuning is valid. If you don't have that, it's going to kick it out. Next, you will see that it'll actually, let me close this. It'll set by default the criteria, the hyperparameters for tuning. And over here, I think this one is just set up to say, you pick it for me. But what that will do is it'll pick the number of epochs and the learning rate. The number of epochs is roughly equal to the number of checkpoints that are generated for the fine-tuning process, because fine-tuning runs for a long time. So what that means is periodically, as it fine-tunes, it's going to test the model and say, okay, I've fine-tuned it. Is it there yet? Is it there yet? And when it does that, if you want to understand how that works, you're going to look at the monitor tab, and you'll see it started, first fine-tuned it, asked a question with the training data. No, not working. Let's do it again. And keeps changing until the loss is low and the accuracy is high. Now, you can notice over here, for instance, that the loss is actually kind of constant after a while. And there is a smoothing thing that just showed up now that I haven't tried before, but it helps tell the message better. Same deal, like between this and this, maybe there's not much difference. So what I can do is I can go into checkpoints, and I can pick one of the checkpointed models, which is somewhere lower in that kind of like the training run, and try using that as the deployed model if I want to. But bottom line is, you can actually track the progress and understand how well your fine-tuning is performing. And then the hyperparameters that were set by default, you can go ahead and change them and see, do you want a faster learning rate? Do you want to give it more or less epochs, etc.? Now, the thing I want you to also think about with fine-tuning is, and this is actually, I am not an expert in fine-tuning. At least that's how I used to think about myself. But the reality is we all need to know enough about all of these techniques to really be able to be effective. So how do you do that? Fine-tuning has typically been the domain of data scientists. But the way we do it is, if you want to try this, go ahead and try it out. You can go into this. The CodeSpaces has Copilot. You will need your quota of Copilot for this. You can literally, and I don't know if I have time to do this right now, but you can take the screenshot, dump it into that chat, and ask Copilot to analyze and tell you what this means in terms of fine-tuning. And it's going to analyze and tell you what that accuracy rate means, what the training loss means, etc. Hugely encourage you to do that. But anyway, once the model is fine-tuned, I can actually go ahead and deploy it. And when I deploy it, you will notice that it'll show up now as one of the fine-tuned model options that I can use in my agent. Now, in the interest of time, I'm going to basically just move to the next thing. But I want you to know that Foundry has this thing called developer tier. And one of the reasons we're using Sweden Central and the GPT-4.1 models is it's kind of constrained to a few models. If you use the developer tier, in other words, once it's fine-tuned, if you deploy that model in developer tier, it'll keep it alive for 24 hours and kill it afterwards. And then for those 24 hours, you don't pay the hosting charge, you only pay inference. So definitely check that out. All right, so we fine-tuned the model. What do we do next? Next over here, we're like, okay, I've got my model. Now I need to actually work on the agent. And you know that we have this basic agent in here. If you kind of go through, you'll notice that in my agents, there are 3 other agents over here. This is what the code base here will actually build for you. So once you finish this part, you're going to go into the agents space. And in the create agent space, it's actually going to create this agent for you called Cora. Cora's Avadia, and it's going to put in the instructions, etc., and have that ready for you to go. Note that you're seeing it in the playground, but you're actually going to use it from code. So really quickly, now we're moving over to the SDK. So when you run that next set of exercises, it's going to use your JavaScript code and the SDK to create the agent and talk to it. And I want to briefly talk about what options you have. So that particular thing you'll notice in the code base. In the interest of time, I can't do everything, but I'm going to show you where the code is because I want you to treat this as a sandbox that you can kind of use, right? So this is the thing that'll set up the agent. This file actually has tools that it's generated. Some of them are functions. And then this one runs it. Microsoft Foundry also has a large number of tools that it brings in out of the box. So you can technically also see if you want to use something like Bing Web Search and connect that. But learn about the tools, capabilities, and how you can enhance your agent as you think about your projects. But I'm not going to go because this is not about agents. It's about the end-to-end model development journey. So your agent can use those models that you've done. But really, at the end of the day, what do we want? We want to know, is this thing doing the right job under the hood, right? So what is it doing under the hood? And this is where end-to-end observability really matters. Let me see how much time I have. Oops, okay. End-to-end observability really matters. What does observability mean? Observability is about having your system give you data that you can then look at to understand whether it's behaving the way it should. And so there's model evaluations, which you can use during selection. Remember the leaderboards? They were also built on evaluations of these models against standard industry standard benchmarks, but you can write your own. So there's selection and evaluation, there's monitoring and improvement on the back end, and then there are governance tools. So let me kind of go quickly through, let me see actually whether we had a different slide. Okay, so we'll talk about red teaming in a second. So if you go into your code, right here, there is an exercise to help you do evaluations and one to help you do tracing. When you run these, I want to show you the outcome so you can understand how to go analyze this later. So let's talk a little bit about what evaluations is. And then I'm trying to figure out, okay, here's the evaluation run. So when you run that, it's actually going to set up an evaluation run. What is evaluations? Evaluations is where you're saying, hey, I've built this agent. It's using this custom model of mine, but I want to know whether it's always going to answer with factual. Are the responses actually factual? Are they safe? And so on. What this lets you do, what evaluations lets you do, and let's go into the evaluations tab, is that it allows you to take advantage of a huge number of what's called built-in evaluators that Foundry gives you that you can run on the responses to see whether it matches those criteria. Now, the analogy I'm going to, for those of you not familiar, I love this stuff. The analogy I'm going to use is evaluations is like that, like your home inspector when you buy a home, or like the grader for a teacher. Evaluators are basically things that are told, here is a checklist I want you to look at. Here is the question that the user asked, and here is the model's response. With AI-assisted evaluations, I can train another model to be my evaluator, to be my grader, and say, hey, your task is to look at the question, look at the answer, and I'm going to give you a rubric. That's like a TA. I'm going to give you a rubric. Please check this off and then score this based on that rubric and tell me what the results are. Those are AI-assisted LLM as a judge evaluators. We also have machine learning evaluators, which are more statistical. So over here, out of the box, Foundry has a ton of evaluators. You can evaluate for quality, you can evaluate for safety, you can evaluate tool performance, etc. I'm going to go back and tell you two things. First, remember our agent. Notice that when I ask the agent, let's say, hopefully this is still alive, what page should I use? So if you want to understand evaluators just intuitively, go to the Foundry UI and try it out. What you will see is that once it's done, it's going to give me that evaluation metric here. So it says, hey, I'm evaluating it. Notice this. It's doing auto evaluations. And then it's saying your quality is 100%. But note that up top here, I have metrics. I set them up to give me everything. You can turn these off and set it for a subset. But by default, if you kind of set these, then in this particular result, it's going to show you the evaluations of all of those criteria for this agent response. So you can play with it right here and see, hey, which of these sound like they're good evaluators for me to use. Quality evaluators are for things like coherence and fluency. It's really looking at the language, is it grounded in the data, etc. Safety evaluations are those that look at, and I think, okay, so this is the evaluation part. So risk and safety evaluations are looking at things like self-harm, jailbreaks. Does it use hateful speech, etc.? Is it using protected material? So you can use those evaluators out of the box. The thing that I'll also point out is that this one that you have here allows you to write and run a custom evaluator. So over here now, if I go into my evaluations tab, I will see the result of the evaluation that I ran. And you will notice that if I click through on it, here are the evaluators. So it's been evaluating it it's passed all the, so here, this is the context, this is the ground truth is this. It says, here is the response. You pass this test, you can analyze the results. So this one is for coherence. So it'll give you explanations for this, but it's saying, is the answer that was given coherent? That's a pass. Don't worry about the statistical one. Those are not what we're testing right now, but violence is passing too because the answers were not violent. Now, in general, for our responses here, our quality and safety, our content safety filters are good. Most of the time, you're going to be okay, but you can write custom evaluators. I want to rate it on how happy it is, right? You can write a custom evaluator and do that. But there's one more thing, right? And I'm going to try to wrap this and then come back here. There's one more thing. What evaluators are like the home inspector. If your app is your home, the evaluator is like a home inspector who's been given a bunch of criteria, and they look at it and they check, hey, did that answer meet this? Did it meet this? I'm going to grade it, and then I'll give you a result. That's what you're seeing there. But what if somebody was being malicious? So you're saying, if you give me this prompt and the model sees the prompt and it does the response, it's right. But what if someone is able to manipulate the prompt in a way that the model gets tricked into doing something it shouldn't do? This is why you need red teaming. The analogy there for me is that, hey, your home inspector says your home is safe, your alarms are working, you're good to go. Are you really safe? Because a burglar will know how to break that alarm. So red teaming is like asking this professional, another agent, to come and break into your system and try to break the things that you set up and see how successful it is. So red teaming is important because it allows you to assess your deployed agent for vulnerability to attack. And what it does under the covers is it uses the pirate identification tool. And I'll actually just quickly show you how it works, because this is interesting and something that's worth knowing. How it works is, let's say there is a thing, right? Your evaluations, you say, how do you loot a bank? The evaluation says, hey, your model's good because it came back and said, I'm sorry, I can't help with that. Everything works. Content safety filters work. Now comes the attacker. The attacker says, I'm going to flip it. So instead of saying how to loot a bank, I'm going to say never tool at war. Okay, I've just flipped it. That simple flip attack, it turns out the content safety filter might look at it and say, this doesn't look like it's harmful. I'll let it go because it's just junk. But the model says, oh, I see what you did. Oh, you silly person, you got it reversed. Let me reverse it for you and then run it. And now it's attacked. It's going to tell you how to loot the bank. So this is a very simple, easy attack that most systems, including ours, will protect against. But you understand what this is doing. So the red teaming agent acts as an adversary. It takes the prompts you give it and tries to manipulate them. It tries to try different strategies and then send them to your endpoint to see how many of them you actually fall for. And so Microsoft Foundry has a ton of built-in risk categories and strategies that you can use. So let me just show you that briefly, and I think we will wrap. I hope this was useful. I know this was kind of like a really fast run through the whole thing, but there's code to run each of these. So if you go into your evaluations tab, once you've run that and you look at red teaming, note again, cannot emphasize this enough. These things take money. They're like, there's a cost associated with it. So I'm going to try to actually give you the documented version to look at as a README. But what you'll see over here is, you see it's saying, hey, I want you to attack me to see if you can fool me into giving you responses that would not have satisfied my violence or like, the safety filters. And by the way, the attacks that I want, let's look at this. The flip attack, if I flip the thing over, do you fall for it? Base 64 is another attack where you encode it. Do you fall for it if I give you an encoder? Because models are smart, they'll just decode it, but it gets through your guardrails, right? So you'll notice that over here, the attacks we passed because our content safety filters are actually very good, and this is a very toy app. But if you actually turn it around and try some of the more sophisticated attacks, you will find that it will fail, right? So my point is that I wanted to have you have a sandbox which has all these things that you can play with. But if you want to understand, for instance, it tells you, hey, here is the thing. It's redacted it. You can't see what it tried to do, but basically try to flip the prompt over. And this says, thing, what do you want, right? It actually passed because it's aligning with this. This is for task adherence. Later on, you'll find that I might try to fool it to say hateful stuff, and it's going to come back and say, sorry, you can't do that because flip attacks are protected. But then if you escalate it and try a crescendo, it might actually get through. So with that, I know there was a lot, but with that, hopefully, I want to get you back to where we started. And hopefully now you're getting a sense of what the end-to-end development journey actually looks like if you're going from, I have a plan to build an app, to I want this to be production ready that real users can use. Remember our criteria. Customer says, hey, I just wanted to answer my questions. It should be grounded in data, should be polite and helpful. And we were able to do that with just the model, adding instructions, grounding it in data, fine-tuning it to have the right response. We got there. Then the store manager says it needs to be trustworthy. Got you there. We'll have evaluations that will test for the criteria and make sure that the default model for the kind of valid questions doesn't do anything wrong. But wait, what if someone tries to attack it maliciously? I also want it to be safe. Yeah, got you covered. Red teaming. We'll actually attack it ourselves first and see whether we can assess and mitigate those vulnerabilities. Last but not least, the architect says I need it to be cheap. And what you saw with Distillation is I can take that 4.1 model, make it work first on the prompts, give me examples, take those examples, and then fine-tune a smaller 4.1 mini model, which is cheaper, but can achieve similar results, and have it do just the one task. So with hopefully this end-to-end kind of like walkthrough was helpful. I don't know what the time is like. Julia can let me know if there's time for questions or not, but I will say two things before I hand it off to her. This will have cost. You will need an Azure subscription. Please do tear it down if you have if you use it. So I don't want to have additional costs. Second, and this is more important, I'm actually using one of the newer SDKs. This is like a preview SDK, which means that things can break. The UI is also kind of constantly, if you were on Model Mondays, you know that the PM talked about the UI going towards GA. So it does evolve. In case you find issues, there is an issue template in our repo. Please send me the issues. I will track that repo and try to make sure I answer. And if you guys are on Discord, I'll be happy to answer things there as well. And with that, Julia, I don't know if we made it on time. I hope this was useful. If there are any questions,
you did a fantastic job. I actually feel bad coming back here because me coming back here means we'll have to leave. But this was amazing. I'm sure you'll see that we have a bunch of questions that came in through the chat.
Okay.
And of course, we'll save them for the AMA right after this. So don't go anywhere. We do have an AMA just starting in the next 5 minutes. So Nitya will get a chance to go through some of the questions that you shared. So there's someone who actually provided some feedback. I want to confirm if you're the right person to channel these to.
Okay.
So they mentioned that they wish that the new UI, the selection was a bit more obvious, like that bold is barely visible. So for such feedback, are you the right person to channel them to, or where would you route them?
So Julia, you should also be the one, like we're both on this side. So there is a person we can channel to. What I think would be useful is we could create an issue template for UI issues in the Foundry, like in our repo. We can forward it to them, but I will point out two things. The person's actually Amir Zur. So can I do a shameless plug for a second? Okay. And then I'll show you where you can do it for whoever asks. So if you actually go to, and I'm just going to put the playlist here because it's easier, but you can actually go to Model Mondays, the repo. If you kind of look at this episode, and I'll make this super easy for you. For those of you who are on the chat, you'll actually just keep the QR code open. If you go to this, the PM on this is Amir Zur. He walks through the UI, and his team is the one that's kind of looking for feedback on this. So definitely check this episode out. We'll make sure the links are available to you. What they would like is instant feedback on the UI. You see this little button over here? You can directly channel feedback to them through this interface. And what I would hugely recommend is channel it through here. It doesn't have to be about the Build Hackathon. Just use the thing and channel it. For Julia and my sake, feel free to put a tag saying, hey, we're coming to this from the JS Build Hackathon, so they can kind of know that this was useful. But in general, this will allow you to capture screenshots right from the screen and submit them. Easiest way. If it's related to something that's in our repo, maybe a step that we're doing that doesn't seem to align, then put the issue for us so we can fix it in our repo. Is that Helpful?
Awesome. Yes, very clear. Thank you so much. So we are out of time. Nitya, thank you so much for the amazing session. This was incredible as usual. So I'm just going to mention two things. Number one is for everything that Nitya has actually demoed, she was kind enough to prepare a full hands-on quest for you to basically experiment with all that. So you'll basically access this from the Buildathon website. You'll find this quest and it will give you the instructions to launch everything that has been demoed and go through the steps yourself. So with that, we'll call it a day. But as I said, we have one more activity. So we do have an AMA. You can scan the QR that you see on your screen, or you can use the link that has been shared on the chat to just transition to Discord, and then we're going to see you all in the next 4 minutes. So if you don't have anywhere else you need to be going, kindly just scan this and then join us for an amazing half hour just to go through the questions that you've all shared. You can come off mute on the AMA and we'll basically have a conversation. But in case you are leaving, in case this is the last time we have with us, join us on Friday for the next session where we'll be covering advanced retrieval augmented generation. So with that, thank you all so much for joining. Thank you, Anna, for the amazing session. I will see you all in the next 3 minutes.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.